Alright class, we're going to go over how to build a series circuit and then a parallel circuit. Alright, so let's take a look at the parallel circuit. Alright, so the parallel circuit has, in this prototype, we have three LEDs operating, functioning separately from each other. Left-hand side, the columns got the negative here, positive here. All three LEDs are plugged into the positive, going into the anode side of the LED. Cathode is jumping over to the resistor, which is plugged into the negative side going out. Same thing here. Here I decided to put in a push button to demonstrate what it looks like when I take one of these out of the circuit. In a parallel circuit, these will continue to function, and this will go on and off with a push of a button. So let's go ahead and jump into the instruction here real quick. Alright, so we're going to start off with 3 resistors. We're going to change them all to ohms. We're going to put in some really low numbers just to kind of see what happens. Rotate this sideways. Just less corners I have to go around. Rotate my LEDs so that the pins can go into separate rows in the middle. Because in the middle of your breadboard, the back of the breadboard is hooked up in rows, and the left and right columns, the positive and negative right columns, are hooked up vertically. Alright, so line these up. So I'm going to bring the red positive wire coming into the right hand side column, with the negative going to the other side of the breadboard. Just wrap around the breadboard, click, and then you can change the directions and the wire will curve for you. Click, hold, and drag to square it up, and color code. Alright, so there's a cathode, anode. Anode is going to be connected to the red positive, and then we're going to drag the connection from the cathode across to a resistor and then onto the negative side. Alright, so cathode row over to the resistor, and then we're going to branch over to the negative column and repeat. Alright, so you're going to see what happens when I put the power to the circuit with the low resistance. The LEDs are not going to like that. And you're going to see a little warning come up. Of course, in real life, you'll just see smoke. You'll burn up the LED, and one problem we have is when students burn up LEDs, they just take the LED and throw it back into the case, and then we end up with a bunch of LEDs that we're not sure why they're not working. So if you burn up an LED in a real lab, make sure you throw it away. Alright, so we're going to put in a switch just to show you. With the switch, you have to go diagonal. That's just the way it's set up. Because if you go straight across from each other, it's just going to remain in the on position. And you can see the little warning lights come up on the red and blue. That means your resistance is too low. And you're going to get that, the rating for that LED is set, and you have to make sure the resistance is the proper amount. And in future lessons, I'm going to show you how to calculate the current going across a resistor and LED. Show you the formula on how to calculate that. So I know that about 175 ohms is about what you're going to need to not blow up those LEDs. And resistors can be hooked up, doesn't matter what direction the current's going through them. It does matter which direction the current goes through the LEDs. So anyway, so the parallel circuit, you can see that the green one's not lit up, but the red and blue light up. So in a parallel circuit, this is what happens. And then I can put the green into play with no effect on the red and blue. And that's the benefit of a parallel circuit. And you can see my component list. It shows the values and the number, the quantity. This also helps you break down the cost if you want to build this, because then you can go and say, okay, tell the clerk I need 300 resistors and 2,000 LEDs, and you can actually have a cost, get a quote, get the school to pay for it for you if you want to build a project. Anyway, so that was parallel. So now we're going to see, we're going to build a series circuit, a little bit different. You can see that one leads into the other and leads into the other and leads into a resistor, leads back to the power, and this is a series circuit. Current is going to flow, and you get cut off if you take one of the LEDs out, or you push the button, it takes the entire thing out. Unlike a parallel, other LEDs keep on going. In a series, they don't. So let's take a look at this is your dashboard. Go to circuits. I didn't show this in my parallel prototype, but create your new circuit, and there's your library of stuff you've created. And bring a picture, find my picture of my series, and I'll keep that handy. Okay, create new. Breadboard. Breadboard, LEDs, resistors, push button, power. And once you get to where you're really good, you can skip on the breadboard and just go straight into the straight wiring. The breadboard just allows you to take components on and off without changing drastically the design of the circuit. So let's put in power, double A's, here's your 9-volt. So double A's, and then you click on the count for, let's add 3 batteries, and let's put a built-in switch so we can turn the power off at the source if we want to. Click and do that little rotation button, and then we're going to bring in LEDs, push button, and resistors. Or actually just one resistor since it's a series circuit. So we're going to do 3 LEDs and resistor and push button. There's my push button. And then those DPT switches that those are a lot of fun, where you can kind of control everything at one point, especially when you have like multiple projects on the same page. You can have 4 or 5 different breadboards doing different things. So we're going to put 400 ohms on that. Make sure you go ohms. Default is kilo ohms, which is way too much resistance. We're just and in future lessons I'm going to show you how to convert your kilo ohms to ohms and other values. Alright, so the series, it's a little bit more detail oriented than your parallel on how you lead in and lead out on your wires, and make sure that your button has to be rotated to where those are going out to rows. They have to be in separate rows. And I'm going to put my resistor on the side there. So there's my negative. Positive. And color coding. Color coding is important because it just helps you keep track of the direction flow of the current. Cathode is going to be hooked up to the negative, but I'm going to put in the resistor is going to go. So yeah, I'm going to plug in the resistor to the right-hand side of the prototype breadboard, and then I'm going to bring that into the cathode. So I'm just going to bring a wire. I'm going to use the middle of the breadboard to kind of channel all of my wires. Alright, and then so that's the cathode side of my LED. Now that's the cathode. That's going to lead into the anode of the red LED. The cathode of the green goes into the anode of the red. So the flow is going the same way through all of the LEDs. And so that cathode is going to go into the anode of the green. And then the top red is going to plug into the switch. And these switches have to be diagonal connections. It's just the way they've got the wiring that goes through these switches. The push button, different buttons do different things, but push buttons, you have to hook them up diagonally. All right. So the red's going through the top red one. It's going to lead in. It's going to contact the anode first. Go out the cathode, and then in the anode of the green, and out the cathode of the green, into the anode of the bottom red, and out the cathode into the resistor and back into the battery. All right, so that's pretty much it. I cut the video off a little bit too quick, but that's it. And so the push button controls the flow of electricity going through, and that is a series circuit. It goes all the way through to the battery, and you can control, of course, you can control the power at the source of the battery, and then you can control in the circuit itself. And so that is your that's it. That's both series and parallel. Parallel probably a little bit easier to design because you can add different projects that kind of vector off in different directions. You can put LEDs and motors and different things. And series is a little bit different. You have to make sure that get your wiring correct. And that's it. That's an introductory lesson to breadboarding with series and parallel circuits. And we're going to calculate the minimum values that you need for resistors to match the power going through and the components you have throughout the circuit. We're going to do that in a couple lessons here. I just wanted to get you guys used to using the breadboard and hooking up power and making sure that you get your electricity flow going correctly through your circuits and understand the cathode and anode of LEDs. So that's it.